or underground projects. Fiber for concrete, they appear in all colors, shapes, size, and material, and sometimes the specific technical strength and weakness of the different fiber are often less well known or lead to confusion. There is no good and bad product, but the right product for the right use and the right testing method for the right performance. So I just go very quickly on the different products you can find on the market. Is mainly steel fiber, macrosynthetic, and microsynthetic fiber. The behavior of fiber reinforced concrete is more than a simple superposition of the characteristic of the concrete matrix and the fiber. To analyze the behavior of this composite material, the interaction between both has to be taken into account, means the transfer of loads from the concrete matrix to the fiber system. It's a mixed design, it's a combined solution, the right mixed design with the right type of fiber. So for an efficient load transfer, the following three main conditions must be satisfied. First, sufficient exchange surface rate means the number, the length, and the diameter of fiber will play a big role. The nature of the fiber matrix interface to allow a proper load transfer, the mixed design should be adapted to the fiber reinforced concrete dosage. And of course, the intrinsic mechanical property of the fiber. E-module, anchorage, tensile strength, shape will allow the force to be absorbed without breaking or excessively elongating the fiber. What can we learn from the material property already with steel and polymer? Key difference is the E-module. E-module of steel, 210 GPa, the tensile strength from 1000 to 3000 MPa, the density, the melting point, and the creep behavior in tension. The E-module of polymer is much more lower. The melting point is very different. So that's conduct to different use of these different products. And steel fiber are the most suitable structural reinforcement material, especially considering the low deformation and cracking control. E-module is sufficient to reinforce at least 5 times to that of concrete, and because the thermal expansion equal to that of concrete. Steel fiber allow cracking control. Steel fiber creep can only occur above 370 degrees Celsius, and steel fiber melt only above 1500 degrees Celsius. E-module is important. Low E-module mean big deformation or crack opening, and the main goal is to prevent the crack and to control the crack. This is the reason why steel fiber are used for durability and sustainability, crack control reinforcement, structural reinforcement, service limit state, ultimate limit state, heavy impact and fatigue. For temporary lining, allowing large deformation based on energy deformation, as in mining, steel macrosynthetic could be used. And the PP fiber with a very small diameter could be used mainly for anti-spalling aid at fire to prevent the spalling effect due to the risk of fire. When we are looking to fiber reinforced concrete only solution, we are looking to this type of behavior, hardening post-crack behavior at section level on the beam test. We have to understand that there is different response of structure made of fiber reinforced concrete get different behavior from softening to hardening. So we should not compare the behavior on a hyperstatics test and the isostatics test. Our current offer for underground fiber reinforced concrete, steel fiber reinforced concrete are used in different type of industry, mining, road, hydro, metro, rail. water gallery, utility, CSO, and different applications from temporary spray concrete to permanent spray concrete to precast segment and to cast in place final lining. Different application, different concrete mix, different performance requirements, so different fiber type proposal. And today we will focus mainly on two key applications, which are the precast segment and the permanent spray concrete lining. So let's move to the precast segment, state of the art. Main message today when we are looking at concrete lining, the assessment of concrete lining requires the definition of both sustainability index and mechanical index. Structural safety, sustainable development get more and more the same level of importance. This is the reason why the fiber reinforced concrete could play a good role to meet these two key requirements: structural safety, sustainable development. We use more and more mechanized excavation with TBM, tunnelling boring machine. The technology improves years after year. TBM could deal with different geology, different diameter, and this technology, yes, get a great return of experience today. And we use more and more TBM, not only for metro tunnel, but in all type of industry. Even if we use mainly the TBM in metro tunnel to control the settlement in urban area. So more and more TBM, and in the meantime, more and more precast segment reinforced with steel fiber. The state of the art is summarized in different documents from ITA, ACI, and FIB. The state of the art summarized by FIB Bulletin 83 underline the key following point: durability, advantages at final stage, cracking control during the construction process, higher impact resistance, boosting of the production process, reduction of cost, and sustainability advantage. From more than 300 projects, we get a good return of experience today. As I say, in production is no more an exotic solution, especially for precast segments, from the pioneering in the 90s, from Heathrow Airport in UK, to the last big project like the Grand Paris in France. We see that the fiber reinforced concrete solution for precast segments grow year after year. The number of projects increase year after year. One of the aspects which has boosted a lot the introduction of fiber reinforced concrete is certainly the publication of the model code in 2010. This model code provides some basic design principle, and the model code was served as a base on many projects since this date. Since many recommendation focus on fiber reinforced concrete precast segment has been published from France, the AFTES recommendation, from ITA, International Tuning Association, different publication, one volume, one focus on design principle, one on lesson learned, one on concrete mix and precast production aspect. There is also a publication from the ACI group 544 and the FIB Bulletin 83. Since new guideline from, of course, the Indian Tuning Association, the Singapore, and also recently from DMRC, with the FIB 83 inside as the main recommendation. So I say the model code 2010 published in 2012, it's a pre-normative, it's part of the future Eurocode, it's proposed by FIB as an operational document, and fibers are included in this document. This document has been completed by the FIB Bulletin 83, focus on precast tunnel segment in fiber reinforced concrete. And this document that you can get easily from the FIB website provide a clear guideline on how to characterize FRC material performance, a clear state of the art, and some design principle. This guideline touched all the aspects of the segment, from the material to the transition state loading condition, the TBM truss, the final state loading condition, the fire design, the connector aspect, the durability aspect. This guideline provides detailed durability state of the art, recommendation of the quality control, some sustainability calculation and index, and case study. When we go to the design flow, all start from the beam test. And from the beam test to get material property, performance class, we move to the structure using the constitutive load, the material safety factor, and other impact factor that you find in the code, to the acting load situation, demolding, staking, transport, placing, service, and the resisting load. The most important is to start with the relevant material property. How we get this relevant material property? The main design standard is the EN 14651. So you can see it's a 3-point bending test with notch. From this test, we get two key important values for the design to characterize the material. The first value is FR1 for a crack move happening displacement of 0.5 millimeters. And this value is used at service limit state design. The second value is FR3, is the residual strength for a crack move happening displacement of 2.5 millimeters used for the ULS. This EN standard is also part of, yes, of course, of the model code, the C label, and all the current design codes concerning fiber reinforced concrete. From this testing method, you get two values, FR1 and FR3, and these values are connected to the classification according to the model code 2010. For example, a performance class 5D, according to the model code, means FR1 characteristic should be higher than 5 MPa, and the letter D means the ratio between FR3 and FR1 should be higher than 1.1. And this is the typical specification, the typical performance proposed by a designer according to the project requirement. He could specify a C50 compressive strength. 5D means a performance class mini expected with fiber reinforced concrete. And to check if we get this 5D performance, we have to conduct the EN 14651 3-point bending test with notch to qualify the material and to use the right knee design with the right type of fiber to achieve this 5D performance. Fiber reinforced concrete only means we are looking for hardening behavior in bending at section level. Why? Because this allows immediately a structural utility ULS and cracking control SLS. This is a typical hardening post-crack behavior we are looking for on the beam test. This is an example from Roma University, but we have also similar test result from Chennai laboratory. Here we test 9 beams, which is the minimum number of beams for the pre-qualification test. We get average value, FR1, FR3. From the average value, we determine the characteristic value, taking in account the standard deviation, the coefficient of variation, and the characteristic value allow us to qualify the material. In this case, FR1 is higher than 5 MPa. FR3 divided by FR1 is higher than 1.3, means the performance class could be 5E according to model code. In order to define the characteristic value from the test result, the procedure is suggested by the Eurocode 0. We use the coefficient of student multiplied by the standard deviation, and we get by this way the characteristic value from the mean value. Moving to the main load condition. Transition load stage, demodeling, stacking, landing and transportation lead to bending moment and shear force. Usually design and uncracking in transition load stage, but with increased ductility. A structural condition is the bending ultimate should be higher than the one required at FR3 characteristic. Bursting force, main challenge when designing the precast segment. Indeed, this load case, the concentrate load mainly due during the installation by the application of ram loads to the edge of the segment could conduct with traditional reinforcement due to the minimal concrete cover requirement for corrosion and the particular shape edge to vulnerable edge and spalling effect. And this was the main reason why fiber reinforced concrete was introduced, because you have fiber also close to the surface and you can prevent this risk of spalling, because this risk of spalling induces reparation. Reparation is a cost, it's a durability issue. Who will guarantee the durability? There is many questions behind this effect. Bursting force during TBM truss phase. This is the typical design approach. It's also could be designed by test. It could be designed by the non-linear finite element approach. This is an example of a very positive of return of experience. It's a survey conducted by the owner for a big project in UK, CTRL project, and has been published in Tuning and Tuning magazine a few years ago. 260,000 segments produced with fiber reinforced concrete, just 1 major repair, which is a very positive result. And this positive result has also conducted to use more and more fiber reinforced concrete, especially in UK, because in UK today is more or less 100% of the precast segment are reinforced by steel fiber. Load condition also is the load condition at the final stage. So for that, we make a combination of the MN value, and we get this standard MN curve that we can compute, taking in account the performance class of the fiber reinforced concrete. This is an example for 300 millimeter thickness and the concrete C40 5D. And after we have to check if the load condition are inside this diagram. All start from the beam test, and all could be confirmed also by test scale 1. The two main test scale 1 conduct are bending test. And from this test, we can also observe the crack pattern. We can also confirm the hardening post-crack behavior of the segment. And the point load test to better understand the crack phenomena under the jack loads. And we can simulate also the real jack load that we get on a real project. And this type of test confirm the good performance and confirm the good cracking control when you use fiber reinforced concrete instead of rebars. Durability. Durability is, of course, a very important topic. Most of the projects are designed considering 120-year design life. Segment reinforced with steel fiber having a bending, hardening behavior contain cracks much thinner than rebars, and this crack control participate to a good durability behavior. When we talk about durability, but I refer also to the FIB Bulletin 83, we have to check the uncracking concrete, and on this approach there is a clear consensus of the academic and scientific world to say that fiber reinforced concrete perform better than rebars. For the cracking concrete, there is not a full consensus about the maximum crack width according to the different class of exposure. The main recommendation today is to take in account crack width max of 0.2 millimeter, which is also the recommendation proposed by the AFTES recommendation. And on straight current fiber corrosion, experiments show risk is significantly reduced compared to traditional concrete. So overall, there is a clear add value in terms of durability compared to conventional reinforcement. And this state of the art is explained in detail in the chapter 8 of the FIB Bulletin 83. So it's a topic by itself, so I encourage you to use and to go back to this document to catch the current state of the art on this issue. What are the main developments when we talk about the segmental lining design? One of the main requirements is to increase the compressive strength to allow a fast demolding, early demolding. But higher concrete compressive strength lead to a more brittle material. So we need more steel to meet the non-brittle failure requirement. And it's the same for rebars or for steel fiber. So that's why we have to adapt the type of product also to the concrete mix design. It's frequent to see at 28 days a concrete strength about 60 MPa or even 70 MPa, even if for the structural requirements, a C40 is proposed. So we have a quite high concrete strength, so we need to adapt also for that the type of fiber. And mainly, we have to consider the right anchorage with the right tensile strength. And we see the evolution of our product from 1000 MPa to more than 2000 MPa today. And the main product today used for precast segment is the 4D8060 BG with 2200 MPa, with a network of more than 10,000 linear meter per cubic meter, with 40 kg, considering a diameter of the fiber of 0.075 millimeter, and the LE ratio of 80. The quality of the fiber is due to a combination of factors: the wire strength, the type of hook, the wire elongation, the shape, the length, the diameter, and the LE ratio. When we know well fiber reinforced concrete, it's very easy to recommend the right dosage in the specific concrete mix to achieve a standard performance. 40 kg, 4D8060 BG in a C50 to achieve a 5D concrete. It's something that we can more or less guarantee if we do everything in a correct way. But network is very important. Network is important to achieve the mean value, and network is important as well to reduce the squatter, to reduce the variation in the result. The more you have fiber, the more you have a good network, less variation, and from the mean value to the characteristic value, the gap will be lower. Also, the fiber are glued together because the glue allow to introduce in easy way the fiber in the mix and the guarantee a good distribution. So when we talk about precast segment today, we always talk about low carbon solution. In tunneling project, I quote Charles Allen, a consultant, is generally considering that 60 to 70% of embodied carbon is contained in the concrete lining itself. That means if we want to reduce and to go to low carbon solution, we are really we have to talk more about the concrete lining, the concrete itself. So we have to reduce the steel amount, we have to reduce the Portland cement, and we have to reduce the thickness to get an impact. Just a quick feedback about the breakthrough in Middle East. We have done a lot of projects in Middle East in the recent years for the metro tunnel in Doha, but also for the water gallery in Abu Amur, in Qatar, in Step, or in Dubai. All these projects has been designed with 120 years to 120 years in a very aggressive environment in terms of salt and chloride. To achieve this durability requirement, two solutions in the mix design have been implemented. One is to use less Portland cement, and the other one is to substitute totally the rebars by steel fiber. The main goal was to improve the durability. And by working on the durability, we see that we, in the meantime, achieved a CO2 reduction on the lining itself. If we see this graph gives good information about the main trend from the traditional solution, OPC, ordinary Portland cement plus rebars, to Doha Metro, for example, steel fiber only 40 kg with GBBS and fly ash and decreasing the Portland cement. We get an impact on 75% CO2 reduction on the binder and by 50% CO2 reduction on steel. Less steel to same performance conduct to CO2 reduction. And this is the main trend, and we will not go back to that, I think. Just if Doha Metro have just 0.2 ton versus 0.7 ton of CO2 emission compared to Copenhagen. That means if Doha Metro will be built traditionally, it will be 400,000 tons more CO2 emission. Big impact. So when we talk about measuring the carbon emission, we have also to talk about environmental product declaration, EPD. What is EPD? An EPD is a third-party certification that allows to transparently communicate the key environmental performance indicator of Dramix over its lifetime. For example, our Dramix EPD score is about 0.88 kg CO2 equivalent. This EPD, it's a mean value, and this value declaration are introduced in the main tools to calculate the CO2 project. So the one I mentioned here is a one-click LCA. It's a tool to support the designer to better address the CO2 impact of his design and of his project. And this tool refers to official EPD, to official certification from independent product for each type of product, the cement, the rebar, the steel, etc. EPD are created for reporting, not for comparison, because they cannot be compared on a fair and equitable basis if we don't take the same perimeter, if we don't take the same referential. That's also important to keep in mind. And you have the same for rebars, and of course this is a moving topic, and it could be different supplier, different way of producing the rebar could conduct to different also declaration. One example to illustrate the fiber reinforced concrete precast segment acceptance worldwide is the recent Grand Paris Express in Paris. It's a huge project. It's a new ring around Paris. This ring is about altogether, it will be about 200 kilometers. There is many different lots. Sorry. The first lot was the 16-1, and it was the first time we introduced fiber reinforced concrete for a big project like that. Design lifetime 100 years, total length of this lot 19 kilometers, diameter 8.7, and it's a quantity about 5,000 tons, this lot. And we use 40 kg Dramix 8060 BGP. The role of the owner was very important because the owner, the Grand Paris Express administration, was really pushing for innovation and was really pushing for immediate result in terms of CO2 saving. And I quote the president saying that the use of fiber reinforced concrete for the construction of the segment of the Linear 16, the first in France in underground work, compared to reinforced concrete fiber to reinforced concrete, it's a saving of 5,000 tons of steel for 10 kilometers of tunnels. And this conduct at the end to 10,000 tons of CO2 on average for 10 kilometers of tunnel compared to rebars. Less steel, and we reduce also the quantity of concrete by 2 to 3 centimeters compared to rebars. A lot of publications are available on this project. We make a lot of technical paper, return of experience about and compare the rebar solution, the fiber reinforced concrete solution. So it's very well documented. If you want to get more info, I could share with you. Just come back to me by email. This is also an example of one-click LCA calculation for the segment, comparing the traditional solution design with CM1 with the steel fiber solution with CM3. Another big project, it's a concrete segmental lining for the Forestfield Airport link in Australia. Contractor is Webuild. So in this project, they use a combined solution, steel fiber and rebars, but they decrease a lot the quantity of rebars using 35 kg Dramix plus 35 kg rebars. And also compared to the initial solution with 130 rebars per cubic meter, this solution conducts to an important CO2 saving as well. And you have also a technical paper published on this project. Another example is the Montreal Blue Line extension. Designer is TAIym, 6 km, 2-track tunnel, 5 new station, internal diameter 8.6, 7 plus 1 segment, thickness 350 mm, 40 kg drum mix for the 8060 BG. And this is the detailed carbon counting which has been done by the designer TAIym. Just on the concrete mix design, the unit carbon saving is about 46%. And if on top of that, we take in account the fact that we can also decrease the thickness of the cement from 40 centimeter to 55 centimeter. The reduction in thickness, primarily by concrete cover, recommend it's 60 and 75 millimeter of both entrado and extrado to ensure the durability against corrosion according to the Canadian code. Using steel fiber, you can get the same the structural requirement you need, but with a lower thickness. And this lower thickness conduct as well to a total CO2 saving of 40%. So it's very useful. So the message is less steel, alternative binder, and lower thickness. And these three elements conduct really to an impressive carbon saving. So let's move now to the spray concrete. If we still have a few minutes, I want to talk about this application. Spray concrete lining, it's not new. It's a long story already for more than 100 years. But what we see today, we move more and more to permanent spray concrete structure. Historically, tunnels constructed using spray concrete have been based on temporary spray concrete lining to stabilize the opening after excavation and to contain short to medium-term loads. A waterproof membrane is placed next between the temporary and permanent lining, and after the temporary lining has fully stabilized, a permanent cast-in-place concrete lining is installed to contain the long-term load and provide durability and water tightness. So traditional method, we separate the short-term load and long-term load, and the temporary spray concrete is not considered at all in the structural design. So in fact, it's a great quantity of concrete consumption, which is totally in Europe, which is also, if you take into account the rebound, the thickness you have to apply, voilà, this approach is more and more questioning by the market. For the temporary lining, we use mainly steel winder instead of mesh. This is a well-known application because it's faster, it's easier, it increases safety. This is, I think, well accepted worldwide. But the new concept, which is under acceptance, I will say, even if it's not new, because if we look the ITA report published in 2001, this ITA report refers already to more than 150 permanent spray concrete lining. But due to the evolution of the technology, we move more and more with such solution, a permanent spray concrete lining with optional spray applied membrane. What are the main design change drivers? Of course, the robotization, automated mechanized construction, the survey technology fiber, the spray waterproofing membrane, the higher skill operative people, the testing method, we can get the right performance material, the quality control, to improve in the design technique and standard, and the CO2 saving, which is more and more a design requirement. So all these aspects conduct to the fact that we will consider more and more spray concrete as a permanent lining as well. ITA already published a guideline on permanent spray concrete lining in 2020. And I know that AFTES, French Engineering Association, just published also a new guideline on permanent spray concrete based on model code. And the FIB is also looking to publish next year a recommendation on this application. So we move to a temporary spray concrete led by energy absorption to a permanent spray concrete led by residual strength in terms of fiber reinforced concrete performance. That means when we do the pre-qualification test on job site, until now we were mainly doing only the energy absorption because the concrete was not considering as permanent. Energy absorption was a good criteria to evaluate the behavior of the material and to compare steel fiber with steel mesh. But energy absorption in joule do not provide any value for the designer. That's why now we have also this new EN 3-point bending test on spray panel, which is a EN standard, to determine from this test the FR1 and FR3 value that could be used also according to the model code constitutive law and design principle in the structural design. So on the job site, more and more we have this complete material property determination, energy absorption, and minimum residual strength performance. And this provides a good understanding of the material. And this also approach provides design value for the project to use spray concrete as a permanent lining. The possibility of using permanent spray concrete allow to consider this primary lining for carrying the permanent load. Or in this case, the possible solutions are to consider the primary sprayed FRC lining collaborating with the cast vinyl lining, to consider the primary spray FRC collaborating with the further spray in the second stage, or to consider only the preliminary fiber reinforced concrete lining as a final stage. This is the three current approach. The design principle when we are talking about spray concrete is an empirical approach. The step process is the following. Initial deformation obtained with a ground assessment, definition of initial support based on experience and empirical formulation, starting the excavation of the tunnel, installing a monitoring system, redesign if necessary according to the information we get by the monitoring the system. With this method, the designer is not able to correctly define the safety level of the structure for ULS and SLS. Furthermore, the problem can arise at long term and their effect create difficulty in remediation. That's why we move more and more to an analytical approach, and this analytical approach is much more appropriate for permanent spray concrete lining. Energy absorption, this is the current test, and residual strength, this is the current testing method, the EN 14483. Method B, which is also a 3-point bending test on square panel with notch. And this is the same that the beam test, but the difference with the cast beam, this one we can spray directly the material and we can test the spray material, which is very important to get the relevant material property. Some case study on permanent spray concrete. One recent case study is the West Connect M4 N5 link tunnel in Sydney, 100-year design life, FR3 3.5 MPa, FR4 3 MPa. And one is a recent project is in India. It's a permanent spray concrete lining, testing according to the EN 14651. So we have to, in this case, spray a panel, cut the beam from the panel and determine the FR1 and FR3 value, which is maybe less appropriate because today we can use directly a spray panel according to the new EN standard. Another reference in India, the consultant is BD Consulting. It's the Mumbai Metro Rail Corporation. Typical C42 and a thickness of 300 millimeter using a Dramix 4D 6535 BG. Another recent project, it's the Edouard Montpetit station in Montreal. It's a single shell metal example for a big shaft. First layer of 5 cm of spray concrete is applied as initial support and safety. Then bolts are installed. A spray waterproofing membrane is applied. Then another 5 cm of spray concrete, reinforced shotcrete is applied. And the liner is designed for 125 years service life. For this project also, they use the same approach for the underground station and auxiliary structure. They use optimization of the concrete mix design with slag and silica fume, and optimize the shotcrete lining by a permanent spray concrete lining and a spray waterproofing membrane. And this also conduct to a big impact in terms of CO2 due to the thickness and less steel and less Portland cement. And we do this detailed carbon calculation counting. This is a slide from TAIym. The unique carbon saving using optimized design is about 80%, which is very significant. So in conclusion, not to be too long, the main source of carbon emission in tunnel is concrete. During emission during the construction by conventional method, dry and blast is even more than TBM. Changing temporary spray concrete liner and permanent cast-in-place liner to permanent spray concrete liner, in improving in the meantime the mix design, concrete and type of reinforcement, the CO2 emission can be reduced by 75%. Reduce the thickness of the precast segment combined with less steel and new generation of binder will decrease the CO2 emission as well by 70%. In this holistic approach, process, the high performance steel fiber will be a key role. Model Code 2010 Bulletin 83 provide a detailed design principle. Fiber reinforced concrete could be used safely, considering the right testing method and performance criteria based on the EN 14451 for the cast beam and the EN 14483 method B for the spray panel. Model code, design principle, EN beam, EN plate, material property, combine these two standards and all the recommendations already published. The designer, the contractor could find a very good guidance to design more fiber reinforced concrete lining. Certainly, the low carbon binders are not available everywhere, but steel fiber are. So let's start with that, and that will be already a great start. Thank you for your attention. I put my email, so do not hesitate to come back to me by email for any question you may have.
Hello. Thank you, Mr. Rivaz, for presentation. So now we are open for question answer session. We have one question initially. I'll just it is FIB Bulletin 83 provides various scenarios to consider for the use of fibers for TBM, PCTL. Does a similar standard exist to check various loading scenarios for the use of precast segment for the vertical shaft machines?
Well, there is not no, this document is today focused on the traditional precast tunnel segment, not for shaft, but the design principle should not be very different. So there is no specific recommendation. But today the main reference design standard remain the model code. So the model code could be applied for the precast segment, and this is what is explained in the FIB Bulletin 83. You will get the same bulletin for permanent spray concrete lining. Next stage for shaft, but not available right now.
So do we have some more questions from our participants?
The chat.
Hi, I wanted to ask one question.
Hi, can you just introduce yourself?
Yeah, I'm Akas Malik. So I'm working in Larsen and Toubro construction. So we have some projects, I think, where we can definitely use these technologies, and I hope we are going ahead in the right direction for sustainability. So I was having one query about the permanent concrete liner with sprayed fibers. So in this, we introduced the sprayed membranes also, as you had mentioned. So what about the bonding of this sprayed membrane? So is it acceptable? So has that been well proven all over, or can we design the overall lining as a composite lining in that case? And yeah,
but the bonding is the key topic if you want to consider one single layer. So I will maybe you can refer to the ITA guideline on spray concrete permanent lining. They indicate some minimum bonding, criteria to be applied. But yes, you underline the key issue, and we need more bond. But yes, today, according to the return of experience, we can consider when we use a spray waterproofing membrane as one layer because we get this minimum bonding we need. But this state of the art also is under progress, and the spray waterproofing membrane could be applied maybe safely in certain type of environment. In other type of environment, maybe it's better to come back to the geotexting classical waterproofing membrane. It's I would say case by case and project by project to evaluate.
Okay. Thank you.
Do you have some follow-up questions, Aks?
No, I think it's fine. I just wanted to whether now then if we prove that the bonding is sufficient, we can design it as a composite lining, like a single lining system, the primary and the secondary sprayed lining.
So sorry, I missed. It's the same question more or less.
I mean, so if the bonding is well proved of the membrane, so in that case, can we design the overall lining, the primary and secondary, as a one lining and reduce the thickness overall of the...
If the bonding is well proved.
Yeah.
That's that's the point.
Okay.
And I see also in the chat there is a question about the cost saving.
Can I ask some question?
Yeah.
Yeah, myself Bisway Datta. I am working in Sebak-Rangpur railway project, a new bridge in West Bengal and Sikkim, where we are using 3D SFRS and SFRC also. There's a sprayed concrete M25 and M30 SFRC. Actually, we have a problem. We faced the problem. As per the design of Embark, they just put the parameter. They wanted to FR3K greater than 5 So we accordingly we take the mix design, and it is come 45 kg in 3D, and in in 42 kg in 4D. So my question is that 4D is a more expensive other than the 3D in SFRS. So why not we are going to the 3D instead of 4D? What is the difference of 3D, 4D and 5D? 5D in India is not available easily. It's a Dramix means Bekaert is the patented for the 5D, and in 3D there's a 2-3 more companies in India. So can you tell me if we go with a 3D and 45 kg and other than the 4D, what is the difference?
Yeah, as I mentioned, fiber reinforced concrete is always a composite material. It's the right fiber in the right mix for a given performance. So the difference between the 3D fiber and 4D fiber, 3D is a simple hook with a tensile strength of about 1000 MPa, it depends also, and the 4D is a higher tensile strength and optimized hook. The goal of the 4D is type of fiber is to have a better performance with a lower dosage. So especially maybe interesting for application when you need a high FR1 characteristic value, high FR3 characteristic value to achieve this level of performance without increasing the dosage. That's but it's always a compromise. Huh? So that's why we use mainly today the 3D 6535 BG for temporary lining in spray concrete, energy absorption, less demanding in terms of performance, and the 4D 6545 BG with a high tensile strength, more close to 2000 MPa in the permanent lining, because the high tensile strength is necessary to control the crack in a good way. So there is not one answer. Huh? It's always a compromise, and the choice, the final choice, should be done according to the cost performance and the mix design you use, and after testing validation. I don't know if I answer well to your question, but and also a very important point, especially when you do spray concrete. And you want to get, for example, a performance class according to model code of 3C, the characteristic value is really impacted by the variation in the results. Huh? So we need also to have a good way of testing, a good testing process to decrease this variation due to the test itself. To do a minimum number of beams. Like this, when we calculate the characteristic value from the mean value, the coefficient of variation is not so important.
Yeah, thank you. This is quite convincing. And I have another I observed inside. Actually, I'm working inside regularly. Another things I have observed in when we are doing. Actually, we are doing 100 mm wire mesh short kit, then 100 mm steel fiber in temporarily lining, in initial lining. You may say in M25 concrete. So there is a sometimes we have seen that, but we don't have any answer for that. We have asked to the IIT professor on others expert also. The two layers has not totally amalgamated with this. The first layer of short kit and second layer of short kit has like scale fee scale system. It is some portion is like scaling out. It is observed in our side. Whatever we testing every aspect with look after every aspect with admixture, accelerator, operator, everything we just do in proper way. But this is happened sometimes. Is that for in steel fiber and circuit surface, old circuit surface? Means in spring time is any problem? Yeah, is there any solution for that?
I'm not sure I catch question,
So
but I think you underline also the, sorry.
Biswajit is asking that in their side they have used steel mesh.
Yeah.
First layer as steel mesh and concrete, and for the second layer they have used the steel fiber. So what they are facing is at some region there is no bond between these two layers. So he's asking, is it because of steel fibers or something? So am I right, Biswajit?
Yeah, sir. Yeah,
Okay.
that's I wanted to ask.
He's asking
no,
that
I think the bonding is not due to that. It's not due to the fiber. It's another. Bonding is a very important and key topic if you want to consider as a one layer or single shell. But the negative bonding is not due to the type of reinforcement. Is more.
This is actually a primary lining only. They have not gone to the secondary lining. Okay. So his question is that this two layers are not getting bond, and at some places there is the scaling, like means falling off of the shotcrete shell and all. So this is his question. So we have one. If you are online, Madan Mohan, so you can just ask him yourself. Okay, so he has some series of questions. So one is precast tunnel segments for one ring. So he's just asking about the comparison between precast segment of SFRC and precast segment of the conventional reinforced concrete. So is there any percentage or average price comparison which you have done? So this is one question from Madan Mohan.
It's difficult to answer. We can give a general answer from it depends, because you have the labor cost, you have the production process, you have many parameters to take in account. But for sure, when you decrease more or less 80 kg from 100 kg rebar to 40 kg steel fiber, which is the average comparison, you use the cost of steel is less. You have to take in account the production facility, the productivity, and if you take the full perimeter, it should be done project by project between 10% to 40%, I would say. Voilà. There is not an exact number because it would not be right but just to give you information. And this information is more in the hand of the contractor itself, because to get the exact economical perimeter with all the the data involved, the contractor is in the best position to make this comparison. But if fiber reinforced concrete is developing so much, is also from the contractor perspective, because you have a cost saving. On top of that, you have the quality improvement, the durability improvement, the CO2 impact, but the cost saving for sure for the contractor is very important.
Yeah, it is also saved so much time. Saving of the time, construction time. This a traditional steel reinforcement binding is taking too much time. Rather than the steel fiber save much time, 50% of the time.
So okay, we have one more question from Madan Mohan. He's asking, what are the RCPT and WPT values observed with FRCs? FRS, yeah.
What is the
RCPT and WPT?
RCPT, what is...
Madan Mohan, can you
it
just...
is, yeah. Can you listen? Is it okay?
Yes. Yeah.
It is rapid flow penetration. It is the stray currents we call. Yeah, so it is tested for the durability. So we do two tests. One is the water particle penetration, that is called WPT. Normally in the traditional concrete with reinforcement, it is observed as per the contracts in India. It is 12 millimeters, 10 to 12 millimeters. So within the cover area, external cover. When it comes to the RCPT, it is normal traditional concrete. It is as per the contract, it should be 1,000 more coulombs. So in this context, because when you do the testing with FRC, then it will be with the reinforcement. So how the stray current value changes.
Benoit,
I know
let me
the
answer
traditional
this.
value.
Yeah, Benoit, let me answer this. Madan Mohan, actually, the RCPT test is not required for the fiber reinforced concrete because we do fiber reinforced concrete. This RCPT test just to decide the cover thickness of cover. However, fiber reinforced concrete is a three-dimensional reinforcement, so there is no cover requirement. So that's why RCPT test is not required for the FRC. First thing. And then one
Who is
more.
this? Who is this?
I'm Chandan Mehta. I'm General Manager for Bekaert India.
Okay. I don't agree with your point, because it's a contractual requirement.
It's a contractual requirement. It's contractual requirement for your normal test design, for normal segment design. But now you will see the new guideline on the tender document from the DMRC, where for FRC this test is not required.
Correct. That's for the shotcrete. I'm talking about the
No, not shotcrete, for
lining.
segmental lining. For the segmental lining, DMRC is coming up with their new document. It's a DMRC guideline is there, but now they are coming up with their tender specification also. So in
recently
that,
recently they passed one of the document. That's the document you're talking about.
Yeah. In that document, RCPT test is not for the FRC.
Okay.
And then one more question from Viswajita. I would like to answer that question also. It was related to the bonding. So Viswajit, I'll recommend after doing one layer of shotcrete, and when you do the second layer of shotcrete, keep washing the surface. If your surface is not properly washed, then there may be a lot of dust inside the tunnel. And due to that dust, the bond between your concrete is not proper. So that will be the main reason why your concrete is not bonding properly.
So, Mr. Madan Mohan, are you satisfied or you have some more follow-up questions?
I think there are, I put some more questions. It's okay. If you have time, you can. I talk about this corrosion, steel fiber corrosion. How do you deal with that? When there is water, cracks pass through, water pass through the cracks, and then it will directly get in touch with the steel fiber. Then how does it affect during the long term?
So,
Benoit, please reply again.
No, for the for the corrosion, well, there is the two aspect in the cracked concrete and uncracked concrete. In the cracked concrete, the corrosion of steel fiber has been experimentally quantified in a number of projects. So, and the conclusion say that you have no risk to lose bearing capacity if the crack is lowered at 0.5 millimeter. This is the Brighter Run project. Some other specifications say 0.2 millimeter. So the main idea is anyway the fiber are there to prevent the crack, so there is less aggressive agent that will penetrate in the concrete. And there is also the fact that steel fiber are discontinuous. So if a fiber corrode at the surface, this is just one fiber. But globally, the fiber are well. The passivation of the fiber is quite good due to the cement matrix and protected. So all the experimental study conduct that there is no risk of to lose the bearing capacity. And also crack with less than 0.2 millimeter, you have the self-healing phenomena. So that's why. But if you want to get the full return of experience, the full different survey from different projects and different research programs, I encourage you to refer to the FIB Bulletin Chapter 8 on durability.
Okay.
And this chapter also give you something also on the strike current induced by fiber corrosion. It's also quite well developed.
Can somebody share that so that I can see it?
Yeah, we can share that. Or you can go on the FIB FIB website, but the document could be shared. Can give to the organizer, and he could dispatch to you up to that.
Yes, you can just share it with me. I'll share with the people who do it. Yeah. So we have another question. Since concrete cover is matter of concern in tunneling, how is it addressed for internal and external concrete covers as per contract and code of practice?
You have answered it now, so don't need it again. You said now DMRC contract don't need.
Yes, they don't need the
covers. So yeah.
So we have one question from Shahbag. He's asking, is this used, like this steel fibers used in any metro projects, metro rail projects in India?
Shadan, you can maybe answer.
Yeah, Chennai Metro, we have done some sacrificial ring. After that, Mumbai Metro and Kanpur Metro is the project where we are at the stage of getting final approval. And after that, in the railway tunnel, normal railway tunnel, we have done 50 trial rings in Rishikesh Kanprayag project T4 with L&T.
Thank you, Chandan sir. And
even in our sorry to interrupt, even in our Patna Metro, I think we are planning to implement the same.
Yeah, Patna Metro also.
Yeah, it's in process of discussion.
It's in process. Just for sacrificial ring, you have already get the approval from DMRC.
Yes. So that's also going to come.
So any more questions? I guess it's quite, I think many questions were covered over here. Many answers were also given. And it was quite a good Q&A session we had up till now. So thank you all, and thank you, Mr. Rivaz, for your wonderful presentation on FRC concrete. And I'm sure that your experience will be useful for everyone, and hope our student members also have a clear idea of the topic today. And I like our TI and TAIym wants to congratulate Bekaert and all the organizations which were involved in publishing of use of steel fiber reinforced concrete in metro TBM tunnels, as Chandan sir has mentioned, and also for installing steel fiber reinforced concrete segments in package 4 of Rishikesh railway projects. Congratulations to you and your team. And yeah, I would like to inform all the participants that we will be putting up this webinar on our YouTube platform soon. So you can also have a second go in this webinar. And thank you once again, Mr. Rivaz, for your wonderful presentation. Just share, I'll edit it after.